Hey, this is Jim from DTRSec. This is the 17th video in the Reversing in REnigma series. In this video, we continue looking at our recording of darkreading.com. In the last video, we showed you how to download the PCAP and TLS session keys, and then we used the Wireshark GUI to decode the TLS HTTP traffic. In this video, we will do the same thing on the command line using Tshark. Let's do a quick overview of decoding TLS in Tshark with REnigma. First, we will download the PCAP and TLS keys files in the REnigma GUI. Then, we will show you how to use the Tshark command line tool to view the encrypted PCAP. Next, we will show you how to use Tshark to decrypt the TLS traffic in the PCAP. And finally, we will compare the encrypted and decrypted Tshark output with grep and vimdiff. Now, let's take a look at this in the REnigma web interface. First, start on the REnigma homepage. Then we click on the Recordings tab. Then we click on the Expand button for the recording we want to examine. And then we click on the Details button. And then we scroll down to the Network Analysis section. In the last video, we saw that this recording has a large number of connections on port 443, mostly for ads. Now let's scroll down to the bottom and download the PCAP and TLS keys files. Okay, now for the fun part, the command line. As you can see, we have the files recording.pcap and recording.keys in this current directory. First, let's just go over the basic Tshark usage without trying to decrypt TLS. You can run tshark-r on any PCAP file and it will print a human-readable summary to standard output. I'm going to do this and redirect the output to the file out_tls_encrypted.txt. The full command is tshark-r recording.pcap piped to out_tls_encrypted.txt. Next, let's do a quick analysis of this output by counting the number of lines that contain HTTP. We can do this by grepping the file for HTTP and then piping that result to wc-l to count the lines. The full command is cat out_tls_encrypted.txt piped to grep HTTP piped to wc-l. We can see that there are 207 lines in the TLS encrypted PCAP that have the string HTTP. Next, we will apply the recording.keys file to the PCAP by using the -o option of Tshark. The -o command lets you set configuration options. In this case, we will set the tls.keylog file variable. And as before, we will pipe the output to a file. In this case, we will call the file out_tls_decrypted.txt. The full command is tshark-r recording.pcap -o single quote tls.keylog file recording.keys in single quote piped to out_tls_decrypted.txt. And as before, we will use grep and wc to see how many lines containing HTTP were in the Tshark output. The full command is cat out TLS decrypted.txt piped to grep HTTP piped to wc-l. As we can see, there are 766 lines when we add the HTTP traffic that was inside of the TLS stream. Since the original only had 207 lines, that means we were able to extract an additional 559 HTTP lines from the PCAP. Last, we can view the decrypted HTTP traffic visually using the vimdiff tool to compare the two output files. We will first pipe only the HTTP lines to isolated files called before.txt and after.txt. To do this, we will first do grep HTTP out TLS encrypted.txt piped to before.txt, and then we will do grep HTTP out TLS decrypted.txt to after.txt. And finally, we will do vimdiff before.txt, after.txt. With this view, we can see exactly where the decoded TLS HTTP traffic fits into the original PCAP using packet numbers. You can easily see the individual HTTP requests inside of your TLS traffic. Since these are plain text files, you can easily ingest this data into other workflows as well. If you have any interesting use cases for this data, please contact Jim or Julian from DTRSec and let us know. And that's all for now. If you want to learn more about REnigma or are interested in evaluating REnigma, please visit dtrsec.com. Thank you for watching, and I hope you enjoyed the video.